Hey, welcome back to the channel. Good to see you again. Thanks for joining. Today on the bench I have a Bosch Plena. This is a pro grade mixer amplifier for PA applications, public address. And this is not a stereo unit. This is a single mono amplifier with a lot of power, and this has 4 microphone inputs and then an input for line level music or background music. So this is something you'd find in a big box store, maybe. Well, the power this thing's pushing, let's have a look at this here. This model number is a PLE-1ME240-US, so it's a US version. The 240 suggests that it's 240 watts output, but I was reading in the specs and it can go up as high as 300 and some odd watts if you go connect it to the 70 volt or 100 volt line. 4 ohms, you're going to get 240 watts out of this thing at 4 ohm speaker impedance. So very powerful amplifier, and it is very, very heavy. It weighs 25 pounds, over 11 kilograms, and it is massively heavy. It's quite a brute. So it has so this video is not going to be your typical let's fix it up and show it off. I'm just getting this cleaned up and getting it ready for sale. It is dirty. I want to test it. I want to make sure it's all 100% before I put it up, list it for sale. I don't have any use for it. I just want to get it out of here and give it to somebody that can get it some use and make a little cash on the side here. So it has 4 inputs, and these are selectable between microphone level or line level. And it has BGM. I'm not sure what BGM stands for. It has a master volume with an LED level meter here, signal level meter. Let's have a look at some of the inputs here. So we have 4 inputs. 1, 2, 3, and 4. These 2 are 1/4 inch jacks. These ones can be wired in directly, and each input is selectable. On number 1, we can have a chime. I guess when you push to talk on your microphone, you can come up with a chime sound. I don't know if it does this. I guess it would have like a little sample of a chime sound. Push to talk, and then this switch here is line and microphone. This switch here is for speech or flat for music. This one here is off or phantom. I don't know what that means. And then for the other inputs we have line and mic, speech or flat, and off or phantom. So very configurable. And then we have our outputs here. A single amplifier output. We have 4 ohm and we have our 70 volt lines. Cover it up because when you're pushing this kind of power you can get electrocuted from that kind of output. And then we have an IEC connector, or is it EIC? I can't remember, for power input. And has a rated input power of 760 volt amps. So let's pull the cover off, have a look inside. This thing, I'm really curious what it does inside because it is very heavy. Alright, the screws are out. Let's take the lid. Come on. I guess we have to tilt it up first, then back. Okay. Wow. Look at the dust in here. I'm going to clean this thing out. So it does have a fan that is connected to the output heat sinks to keep them cool. And a massive toroidal transformer here, power supply, and another transformer here. I don't know if this is our output transformer for impedance matching. I'm not sure. But looks like everything is intact. Doesn't look like it's blown up inside. So I have a feeling this thing will just work. But we need to get things happening here cleaned up. I'm not going to be doing any work to it unless it's not functioning 100%. So I guess the next step here is I want to take this outside and get the dust out of this. With the fan, there's a lot of dust. Yeah, I can see dust in the heat sinking assembly. And then we'll get this cleaned up, and then I'll bring it back in and we'll give it a test maybe. I guess that's all we can do. It's going to be a short video, so I know I get complaints all the time my videos are too long. Well, here's your short one for you, like it or not. We're not going to do any work, but we're going to make it short. So let me bring this outside, get it clean, and then I'll bring it back in. Alright, so I blew out all the dust from inside the chassis, and it's quite a bit come out of it. Now, the front panel was disgusting with filth, so I took that off and scrubbed it. And once I took it off, I noticed, you can see all this. See all the dust and filth that gets sucked in from the front. The way this works is the fan, that all has to be cleaned off. Look at this. It's all stuck there. So the way this works is the fan blows out the back, but it's sucking air in from the front. So it's sucking in through all these holes along the bottom of the front faceplate and through the knob holes. And that's where all the dust is coming in. And it's depositing itself on these shafts and making a mess like this stuff. So I'll clean all this up. I also have to blow out some of this stuff here because the air compressor couldn't get into these locations. This is all right. Okay, it looks like I found the first problem. Now I had the front panel off. I was cleaning and relubricating the shafts for these pots, and I noticed something, that the front chassis here is all bent in, like somebody, maybe this thing was put down on its face or something, and all the weight was on these knobs, and it bent the frame in all these positions. Even this, the main volume one's bent. You can see it here, how it's bent in. So I'm going to straighten that out. But problem is the power switch is broken. It's all smashed. It looks like it took a hit, and it's not working. So we're going to have to remove that power switch and try and fix it. Either try and fix it or replace it. Now, let me see here. This thing hogs a lot of current. When you turn it on, I think it said in the manual, it said something like 24 amps of surge current when you turn this thing on the mains. So yeah, it's got to be a really stout switch, something that's going to do the business. And here's another piece of the switch that fell out. So let me get the switch out and let's have a look at it. Alright, here's what's left of the switch. So this piece I found inside, rattling around inside the amplifier. Now I know where it came from. It came from this corner. And this corner broke off because this took a hit and popped this end off. Now, I can take this one of two ways. I could repair the switch. It looks like it's all intact. I just have to disassemble the top, re-glue this piece back on, because this is what holds the back. There's this little raised portion here. It gets hooked on that, like that. But I can put it all back together and it would work, and it would work good. It would probably never cause a problem again. So let me look and see if I find these kind of a hard switch to replace. This one is rated at 10 amps, or sorry, 8 amps. 12.8 amps, 250 volts. You can read that. 10 amps at 250 volts, 8 amps slash 12.8 amps. Is that what it says? 250 volts. I don't know why I guess the different ratings. Some of these ratings are European ratings. The CSA rating is the one I'm worried about. So let's see, let's open this thing up. Fixing it probably be a better solution. Okay. One thing I should do is remove this spring before things go boing and then they're across the room and then I'll never find them again. So let me pull this off. remove the spring, and then we don't have any funny energy going on. I'm going to straighten this pin out. Okay, so that should come off. Come on. Need a little persuasion here. Okay. Yeah. Yep, the switch is fine. See that? Still toggling. So this would work. This has to go hook on these two things. Well, maybe not. Oh, it has to go. Okay, I see. I have to go farther. Let me try this. Set these there. And then, there we go. There. Switch is working. I could put it back together. I would just need to glue this corner. Maybe I'll just do that instead of monkeying around resoldering these wires. I'm just going to epoxy this back on because this is needed for holding the cover on. And then we'll have it back together and it'll work. Let me mix up some epoxy and we'll get that set. Okay, I think I discovered the secret behind this. This latching lever has two different lengths to it. This side is longer than this side. This side, the short end, goes down into the white plastic locking mechanism, the track that does the locking. The long end sticks out the top of the switch. So we put this together like so. You'll see why in a second. That goes in there, and then we can assemble this switch like so. Okay. Now it's not going to function as a latching switch yet because we need spring pressure on the top of this post here. Well, let's put our spring together. Where's our spring? I lost the spring already. So let's put this here. I'm just going to hold this together with my fingers because I don't want to be crimping anything yet. If I had 3 hands, I don't. Can get this clip on. There. All right. The spring pushes the lever, the top of the lever, down this way, which forces the other part into the track. Now it's working. So let's crimp this thing up and then we are done. I'll have to be careful on the back here because I don't want to break anything, so I'm just going to carefully spread this one. Actually, I want it a little tighter. There we go. And then this side, you have to be very careful because we have our glue. Might let go. So let's just crimp this one the minimum. There. We have our 2 front ones crimped. It's not going anywhere. Power switch repaired. Good. I'm going to fix this. I'm going to fix this because I spread it. So let's squeeze this back together. There. Perfect. Put that back in. So these pots, they took quite an impact. You can see how this one's bent. Took an impact. So I'm going to disassemble this. See, this is loose. I want to take a good look at these potentiometers take it all apart and have a look at some of these. Maybe I might have to replace one or two of them, I'm not sure, but I'm going to make sure they're all good. And this one's loose. So see what kind of damage we have on the pots. Just do this. This one here also took a good hit. Yeah, that one's loose. I can see that one's kind of smashed up inside there. Have a look at some of these pots. Don't think I have replacements for any of these. Okay, what is going on here? All right, let's unplug this. Okay, and that was unplugged. That's odd. See how these are. See, some of these are okay. That one's okay. This one here on the end, though. Look at that. This one got whacked pretty good. And the solders on the board are broken. Need to recrimp that. Okay, this one here. I think they might be all right. It's just loose. I'm gonna check these over off camera. Okay, here's one of the pots removed. You can see these two tangs here are spread out, and I don't know if you can see this. Oh, these ones here have lifted. So whatever, it took a hit from the front, it pushed all the junk out the back, and we just need to recrimp this down, kind of like that, and tighten this up again. I don't see anything broken on these pots. That was my main concern, is something broken. But it just took a hit, and yeah, I think, yeah, that even just doing that tightened it up. And this one here is probably the worst one. See how loose that is. I'll remove this pot. These are all 50K pots, and looks like they're all interchangeable. They're all identical. So if I had to take a pot out of the middle here and use it as the main, I could do that if this one's damaged. But I don't think it's damaged. I think it just needs to be tightened up again. I'll remove this pot, and then I'll put this other one back in. And we'll get this working again. These caps, I don't know what to do with these caps. Just check them. I'm just going to test these caps. I think they're all fine. No reason to expect the caps are bad. Yeah. I think we're going to be okay here. I got the pots back in, soldered in. They're secure now. And I did check the ESR on all these caps. They're all good. I didn't expect to see anything wrong with the caps. I was just checking just as... But I think we're going to be okay. Straightened out the frame, and put this all back together now, and we can start doing some testing. Okay, so if you have a look here, you can see they put 2 test points for us. Connect their voltmeter, and then right beside it is a potentiometer for adjusting the quiescent current. So that's how you'd set up your amplifier. I don't know what the spec is right now, but I'll test it and I'll see if it's too high, or if you know, the amplifier assembly gets warm when it's running. I can always turn this down. Not overly concerned about crossover distortion on an amplifier like this. You don't want it there first, for sure, but you don't. If it is there, it's not a big deal, because it's just doing voice. And I noticed these transistors here. These are Toshiba branded. They're TTC 5200s. And I think they are Toshiba's version of the 2SC5200 output transistor, but they're all the same NPN. Like, it's almost as if this is a quasi-complementary. So there's 4 transistors on this side and 4 transistors on the other side. You can see them here. And I don't know if they're using one of these as a driver. They might be doing that, or this might be our driver here. Usually there's 2 drivers. I'm not sure how they're doing this. I haven't seen a schematic, so I don't know what they're doing. All right, got everything together. Got a load on it, 4-ohm load. I have a signal source. I'm not going to turn anything on yet, but let's just turn that off. Let's turn all the inputs down, and let's just power this thing up. Here we go. Okay, clicked on. Consuming 12-13 watts. I'm climbing. Have our light, and we have nothing on our meter, sitting around 15 watts. So everything looks like a go here. Now I was going to connect the scope up to the output, but this is a bridged output, and I don't know if the ground is isolated. So that's what I wanted to check. So let me get my voltmeter and do some checks, and then I'll bring you back in. Alright, so everything's connected. My voltmeter, my oscilloscope, my watt meter, everything's ready to go. Everything's live and powered on. Let's see if we can get a signal out of this thing. I'm feeding into the BGM. I do not know what BGM stands for. I went to the owner's manual, and this says this is an input for audio, music audio. There's 2 RCA connectors on the back for BGM. This is probably Bosch's foolish language for something or other. I don't know. So let's turn this up. A scratchy little pot there. Okay, so let's turn up BGM about halfway, and then we should get our signal. There it is, coming through. Now since this is a mixer, I can add as much. Oh, this is pretty dirty. Pretty dirty controls. I'm going to have to clean some of these. Okay, let's turn down. Let's see if we can get full power out of this thing. Now it's rated at 240 watts on 4 ohms, and I do have 4 ohms connected. Very dirty. There's a little bit of work there. I have to do more work on these pots. Hang on here, I gotta turn this up. Let's do it this way. Let's turn this one up. Maximum. Let's control it with this one. I'm clipping there. It is clipping. Now this does have a limiting circuit, so that when it approaches clipping, it backs off on the signal, and it seems to be doing its job. So for maximum power output, I'm getting 33.56 volts RMS on 4 ohms. That's pretty impressive. Let's leave this on for a while and see if we get any action from our fan. Here it comes. Fan is ramping up. Maximum power. It's blowing out the back. $570 going in. Okay, it's been on full power for about 5 minutes now. I'm just going to shut this down and let it cool. The limiter was coming on. I could see the light come on when I turned it right up. I don't know if you can see that on the camera. But you can't overdrive this amplifier. It's built to protect itself. So I'm just going to let this thing cool. I want to test every input, and then I want to do some pot cleaning with pots and switches. These tone controls I want to test out. So let's feed in a square wave right now. And let's bring a square wave up. Doesn't like. Let's turn down this. Turn down the sensitivity here. Okay, so this is bass cut, bass boost, treble cut, treble boost. So they're working fine. We just have really dirty controls. Just checking all these other ones. Yeah, this potentiometer is a problem. What I'm going to do is switch this potentiometer probably out for this one. This one's clean and it's working no problem. As you can see here, it's not dirty at all. I'm going to switch these two potentiometers out, and then I'm going to test the inputs for the other 4 channels. Alright, just going through and testing all the inputs, and they're all working fine. A couple of the pots are scratchy. I actually took this pot and this pot apart and disassembled them and cleaned them. Those are the worst offenders. But after you work the pot a few times, it cleans right up. So you can see it here. I'll show you. This is the first channel, and I'm feeding it a line signal, and that's full power. If I wiggle the pot, I can still get a little bit of, but the more I work it, the better it gets. I think the problem with this thing is that the fan is sucking air this way out the back, and all the air is coming in through the front panel, through these holes that are punched, and through the knobs, and all the dirt and stuff's getting sucked in with that air, and that's causing all the problems with the pots. A little bit of the green juice there, the deoxit F100, and it seems to clean it right up. So I'm done with this. I'll put the lid back on, and then we'll wrap this up. Well, there you go. It's all back together, and yeah, this is a short video. It wasn't much of a video this week, but I just wanted to go through this, check it over, make sure it's 100%, because it's going to get listed and for sale, and get it out of my hair. It's quite a beast, though. It's very, very heavy, and it's got a lot of power. So yeah, it's kind of interesting. Interesting design. First thing I've seen from Bosch. I got to say it's okay. No complaints. But yeah. Alright, thanks for watching. Take care, and we'll see you in the next one.